Assalamu alaikum students, this is Farwa Batul, your O-level computer science instructor, and welcome to another video. In the previous video, we have seen example number 1, example number 2 of Boolean logic. In this video, we will be discussing example number 3 of this chapter. The example says that, look over here. There is a logic circuit that is represented by the following logic expression. The logic expression is A or C or not C, then B. Produce a logic circuit. You have to produce a logic circuit and you have to produce a truth table from the above statement. So let's quickly start with the working. The thing that is given to you is the logic expression. So in this example, you will be doing what? Logic expression will be used in order to produce two things, the logic circuit and then the truth table. So this is how we have to do the working. So let's start with the logic expression first. Okay. In the logic expression, we have A, XOR, C in the bracket. Then there is a OR gate. And the next one is not C, NAND, B. By looking at the logic expression, it is very clear that the input values are A, C, and B. So we have three inputs to our gates. Now, in order to make the logic circuit, what you have to do, you have to make or solve the brackets first. This is your bracket and this one is your bracket. So in order to solve the logic expression, first you have to solve the brackets. So the first bracket we have is A XOR C. So if I make A XOR C, it is nothing but two inputs going into the XOR gate. You must know the symbols of the gates. So this is A, this is C, this is your XOR gate. This is the step number 1. In step number 2, you will be solving the second bracket, that is, look over here, not C, NAND B. So I'm quickly writing over here, it's not C, NAND B. Now, look over here. C is not going directly into the NAND gate. C is basically inverted because it's written not C. Not C means that you will invert the value of C first. This is the input C. When it will go to the inverter, then you will get not C. Or we can simply write it C bar. You can write both not C or C bar. So first you have to do, or you have to use the inverter gate in order to reverse or invert the value of your input C. This becomes not C, and the other input that you have is B. And then the gate that is taking both of these inputs is your NAND gate. So NAND gate will be simply the reverse of your AND gate. So it's like this, NAND. This is how you can make not C, NAND B. Remember that if there is not with any input, then it means that input will be passed through an inverter before going into the other logic gate. So that's why here we have passed C through an inverter first. That becomes not C. And the other input we have is B, which is going directly into your NAND gate. That's it. This is done. Step number 1 and 2. Now, again, moving towards our logic expression. Now, these two brackets or these two circuits are going into another gate. Once you will get the result of these two, this one and this one, then you have to pass it through an OR gate. So it's very simple. Step number 3 is your final version or logic circuit 1 that you have made. 1 will be OR with logic circuit 2. That is step number 2. So in the logic circuit 1, we have seen that A and C are going into a XOR gate. Next, we have seen that in the other we have a NAND gate, but in the NAND gate, one is input B is going directly, but input C, don't make lines for C 2 times. You have already input C, you will just put it or pass it through an inverter and then it will go to a NAND gate. This is how you can combine logic circuit 1 and logic circuit 2. Then finally, these two will be connected through an OR gate like this. So this is a final version. It's a OR gate. This is your XOR gate. And this is your NAND gate. And this one is simply an inverter, the NOT gate. So this is the final version of your circuit. This is the logic circuit that you require in this example. So we are done with the logic circuit. Now we will be making the truth table. So let me quickly write down the truth table for it. But before doing the truth table, remember that you should know the intermediate inputs. What are the intermediate inputs? It means that whenever your inputs, the initial inputs passes through any of the logic gate, then the logic gate is going to have output for it. And if that output is not the final output, so you mark it as intermediate inputs. So at this point, here, the output of XOR gate will be marked, let's suppose P. Then you have inverter, I small or simple logic gate. The output of this logic gate, we know that it is C bar, but we are going to mark it with alphabet Q, so that the truth table will be easier to make. And for the NAND gate, we have another output. Let's mark it R. So these are the intermediate outputs. They will help us to find out the final output, which will be coming from the OR gate. Let's mark it X. So I'm quickly showing you the truth table and then we will fill it. Okay, so let's quickly do part B of this example. In part B, you have to make the truth table of this logic circuit that you have just produced. Okay, so look at this. The input values are A, B, C. The intermediate values are P, which is the output of your XOR gate, then Q, which is the output of your NOT gate, and R, which is the output of your NAND gate. So I'm just writing down to make it simple or understandable for you. And X is your final output, that is the output of your OR gate. Now quickly write down the input values. Since there are 8 combinations of your input, because we remember that it is from the formula 2 raised to the power n, where n is the number of inputs. So A, B, C. These are my 3 input values. Write down 3 over here and you will get 8 input combinations. Now let me quickly tell you that what is the method of making these combinations different from each other. Starting with this column, the last input value, that is C, you will make it 0, 1, 0, 1, 0, 1, 0, 1. We will put the alternate values. In column B, you have to put the values like 2 zeros, 2 ones, 2 zeros, 2 ones. And then it is basically in the order of 2 raised to the power 0, then 2 raised to the power 1, and then 2 raised to the power 2. 2 raised to the power 2 means 4. 4 zeros and 4 ones. 2 raised to the power 0 is 1. I'm just explaining it to you that how we make up these different input combinations. So the first thing is 2 raised to the power 0 is 1. That's why we have put the values alternate. 0, 1, 0, 1, 0, 1, 0, 1. 2 raised to the power 1 is 2. That's why we have put values like this: 2 0, 2 1, 2 zeros, 2 1. And for the third column or third input, 2 raised to the power 2, which is 4. So that's why we have put the values 4 zeros, 4 ones, 4 zeros, 4 1, 4 1. So we will follow this pattern. Now, let's quickly do the XOR gate, that is P, the values of P. Okay, so XOR gate is basically taking A and C. So it will be A XOR C. So let's see the values of A and C. And you have to put the result of XOR over here. So remember that the XOR gate works as if you have similar values of your input. Similar values means if it is 0 0 or if it is 1 1, then you will get a 0 output. And if there are dissimilar values, it means one is 0, other is 1. One is A is 1 and C is 0. Dissimilar values, you will be getting 1 as your output. This is how the XOR gate works. So look at this. In the first column, look at the values of A and C. Both values are same. So you will have a 0 output. Similar, 0 output. Dissimilar, 1 output. The next one is 0, 1. 0, 1 dissimilar values, put a 1 in the output. 0, 0. Similar values, put a 0 in the column. 1, 0, 1. Dissimilar, put a 1 here. 1, 0. Dissimilar, put a 1 here. 1, 1. Similar, put a 0 here. 1, 0. Dissimilar, put a 1 here. 1, 1. Similar, put a 0 over here. So this is the result of your XOR gate. Now let's do for the second column or the second intermediate value, that is your Q. Q is nothing but it is the reverse. Look at your logic circuit here. It's the inversion of your C. So all of the values of C will be inverted. So look at this. In the first column, you have 0. You will put 1 here. Then 0, then 1, then 0, then 1, then 0, then 1, then 0. This is how when you pass the input of C into a inverter or a NOT gate. So all of the values will be inverted. So you just need to see the column of C and invert all of these values. 0 will become 1 and 1 will become 0. Now quickly do for the third intermediate value, that is your R. R, what R will do? R will basically use not C, or we can say it is going to use the values of Q and it will NAND with P. Not P, sorry, B. Look over here. This is your NAND gate. NAND gate is taking B and Q. So we will consider two columns over here and we will make it NAND. Let me clean it for you to explain you the values of R. So here we go. For R, we will consider values of Q and we will consider values of not C and B here. These two columns will be considered. And what is the operation? It's a NAND operation. So a NAND is nothing but it is the reverse of your multiplication or AND gate. We can say it is a not AND. NAND is a not AND. So in this, when you have 0, 1 or 1, 0, dissimilar values or 0, 0 or 1, 1. Let me quickly tell you for that. 0 into 1 is 0, but we will make it 1 because it is inversion of your multiplication. 1 into 0 is 0, we will make it 1. 0 into 0 is 0, we will make it 1. Only 1 into 1 is 1, but we will make it 0 because it's the inversion of your multiplication. Okay, we will keep these values in front of us so that we can easily do for values r. Okay. Sorry for this. 0 into 1 is 1, 0. We will make it 1. Now quickly see the values of b. 0, 1. 0 multiplied by 1 is 0. We will make it 1 in the column r. Then the next 0, 0. 0, 0, 0, make it 1. You have to write the reverse of your multiplication result. 1 into 1 is 1, make it 0. 1 into 0 is 0, make it 1. 0 into 1 is 0. 1 into 0, 0 into 1, 0, make it 1. 0 into 0 is 0, make it 0, 0, 0, make it 1. 1 into 1 is 1, make it 0. 1 into 0 is 0, make it 1. This is how you can fill your NAND gate. Okay, so once we are done with R, now let's do for X. X is nothing but it's an OR gate that is taking two input values. Quickly see the input values for your OR gate in the circuit. Okay, so the OR gate over here is taking P and R as the input values. So for the OR gate, we will consider the values of P and R, these two, and we will make it OR. The OR is simply the addition of your bits. Let me write it over here that OR gate functions like this. If it is 0, 0, 0 plus 0 is 0. 0 plus 1, 0. 1 plus 0. Sorry. You need to be very careful. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, also 1. So this is how the OR gate works. Now quickly see the values of P and R. The first one is 0 plus 1, 1. Then 1 plus 1, 1. Then 0 plus 0, 0. 1, 1, 1. 1, 1, 1. 0 plus 1, 1. 1 plus 0, 1. 0 plus 1, 1. This is the final output or the value of X that you will be getting. So this is how you have to do this example number 3. Be very careful about the values of your truth table and you have to cross-check it again. Okay, so stay tuned, stay connected. Do not forget to subscribe the channel. In the next video, we will be coming up with another important example. Bye-bye.